14 is all about acids and bases. So section 1 talks about properties of acids and bases. The objectives here, we're going to do this section fairly quickly since it's a lot of information you can read or listen to the video like I've told you before. So, list 5 general properties of aqueous acids and bases. Name common binary acids and oxyacids given their chemical formulas, which you guys should possibly know how to do. List 5 acids commonly used in industry and the laboratory and 2 properties of each. Define acid and base according to the Arrhenius theory of ionization and explain the difference between strong and weak acids and bases, which we will go over. So, if we want to begin with acids, the properties, there are 5 major properties that you should learn. 1. Aqueous solutions. What does aqueous mean? That it's in water. Of acids, have a sour taste. Okay, they may have a sour taste, but do not taste the stuff in the laboratory, guys. But things like, if you think about things you've eaten, vinegar has acetic acid in it. Lemon, citric acid, stuff like that. So number 2, acids change the color of acid-base indicators. If we look at pH strips, an acid shows a different color than a base. Some acids react with active metals and release hydrogen gas, H2. So if we look at barium, which is a metal, reacts with, what's this acid? Sulfuric acid, to make barium sulfate and hydrogen gas. So, number 4, acids react with bases to produce salts and water. So when you have an acid and you want to neutralize it, you add a base, and then that produces its salt and water. Number 5, acids conduct electric current. So some acids completely separate into their ions and then become strong electrolytes. So if we look at binary acids, what does binary mean? Bi meaning 2, so it contains 2 different elements. Hydrogen being one of them, and then an electronegative element, and we know that fluorine is the most electronegative element, so we see it makes HF, HCl, HBr, and HI. But how do we name these? Oh wait, there's more. So first, to name a binary acid, it begins with the prefix hydro. So if we look at these, each one of these are going to begin with hydro. Then the root of the name of the second element follows this prefix. So we say, oh, this is, what's F? Fluorine. So the root being fluor. So we would say hydrofluor. How do we end it? The name then ends with the suffix ic. So we would say hydrofluoric acid, hydrochloric acid, hydrobromic acid, and hydroiodic acid. So, once again, here are the formulas along with the names of binary acids. The only one here not mentioned on the slide prior is hydrosulfuric acid, not to be confused with just sulfuric acid. So hydrosulfuric is H2S, also known as hydrogen sulfide. If we continue to different types of acids, we're talking an oxyacid, which we went over briefly before. This one contains hydrogen, oxygen, and then a third element, usually a nonmetal. So we look at nitric acid and sulfuric acid here. So the nomenclature then follows a pattern. So the names of the anions are based on the names of the acids. So if we look at the next slide, we can see that we've done this before. I ate something icky. So if we say acetate, we get acetic acid. Carbonate, carbonic acid. Remember, the dog bites something delicious, or I bite something delicious. So it goes from ite to us. So we say chlorite, chlorus, chlorate, chloric. So remember, ate to ick, ite to us. So, the common industrial acids. There are 5 common ones that we will discuss. These you should know. Once again, what's this? Yeah. Sulfuric acid. Nitric acid. What's that one? Have we seen that? I think you have. Phosphoric acid. Acetic acid. And then the binary hydrochloric acid. So, starting with sulfuric, let me tell you a little about it. More than 37 metric tons of it is made a year in the States alone. It's used in petroleum and fertilizer. It's used in the production of paper, paint, dyes, detergents, chemical raw materials. It's also used in automobile batteries. And also, because it attracts water, it can then be used as a dehydrating agent. So if it's dehydrating, it's removing the water. So concentrated sulfuric acid is an effective dehydrating agent. For instance, it's used to dehydrate sugar. But be careful, because sulfuric acid does cause bad burns. Most acids do. So then we talk about nitric acid. Nitric acid, HNO3, is volatile. What does that mean? It evaporates very quickly. So it's an unstable liquid, and the more you dissolve it in water, the more stable it becomes. It's used for staining proteins yellow. It's a very suffocating odor, and it stains your skin, but it also causes serious burns. So don't be like, oh, I want to look nice and pretty in yellow, because you will burn. It's also used for making rubber, plastic, dyes, and pharmaceuticals. It's colorless, but it gradually becomes yellow due to the slight decomposition to brown NO2 gas. And what's NO2? Nitrogen dioxide. Phosphoric acid has phosphorus in this. And then I'm sure in environmental science you've learned that phosphorus is an essential element for plants. So it's used actually for manufacturing fertilizers and animal feeds actually. If it's dilute also, it has a pleasant but sour taste, and it's non-toxic. I'm sure you've seen in your drinks phosphoric acid. It's used as a flavoring agent in some beverages, and it's also used as a cleaning agent for dairy equipment. It's important in manufacturing detergents and ceramics as well. Acetic acid. Acetic acid is, in its pure state, it is called glacial acetic acid. It's clear, colorless, and pungent smelling. Ugh. It's called glacial acetic acid because it actually has a freezing point of 17 degrees Celsius, and it can form crystals in a cold room. Isn't that crazy? The fermentation of plants actually produces vinegar, and vinegar has what in it? Acetic acid. White vinegar actually contains 4 to 8% acetic acid. And it's also important in manufacturing plastics and It's actually a raw material in the production of food supplements. Never thought you'd think that, huh? So, then we get to HCl, hydrochloric acid, the binary of the bunch. What are these? Oxyacids. Good job. So, the binary of the bunch, hydrochloric acid. Did you know that your stomach is actually producing it when you eat? Because that is what people refer to as your stomach acid. It aids in digestion. In addition, they use it in pickling iron and steel. It's an immersion, which is an immersion of metals in acid solutions to remove any surface impurities. So that's what pickling is. Hydrochloric acid is also used in a general cleaning agent, food processing, activation of oil wells, recovery of magnesium from seawater, and the production of other chemicals. If you have a concentrated solution of hydrochloric acid, it's actually referred to as muriatic acid, which is found in hardware stores. It's used to maintain the correct acidity in swimming pools. Who knew? You could find this in your swimming pool. And it's actually used to clean masonry as well. What else do we got? Okay, so now we are looking at the properties of bases. So 1, aqueous solutions of bases taste bitter. So acids, sour, bases, bitter. And you would know this if you ever got your mouth washed out with soap or you accidentally got soap in your mouth. Number 2, bases change the color of acid-base indicators. Once again, pH paper. It will change it a different color than the acid will. Dilute aqueous solutions of bases feel slippery, hence soap. Bases react with acids to produce salts and water. So it's the same thing. They neutralize the acid or they neutralize the base, therefore producing a salt and a water. Bases conduct electric current. Once again, the same thing with acids. They can be strong or weak electrolytes when they dissociate into their ions. So we are going to talk about Arrhenius acids and bases. And Arrhenius acid is a chemical compound that increases the concentration of the hydrogen ions. You see H+, it's probably an Arrhenius acid. An Arrhenius base then increases the concentration of a hydroxide ion. That's OH-. These are both in aqueous solutions. What's that mean? It's in water. So, if we look at Arrhenius acids, they are molecular compounds with ionizable hydrogen atoms. So we have nitric acid. We see that it is in water. And if it's in water, it's known as an aqueous acid. Aqueous acids are electrolytes. So if we look at the products, we have hydronium ion because this hydrogen goes to the water. So now we get a hydronium ion and we get nitrate. So here we have an anion and we have the hydronium ion. So common aqueous acids, if we look at the formula for hydroiodic acid, hydrobromic, hydrochloric, these are strong acids and these are weak acids. So we see that these are reversible. Why? Because these don't completely dissociate into its ions. So it's kind of sitting in the middle with some of this, some of this. It's not completely dissociated into its ions like over here. So strong acids, we see that it ionizes completely in aqueous solutions. There are 6 main strong acids that you need to know. Perchloric acid, HClO4. HCl, hydrochloric. hydrobromic acid, hydroiodic acid, nitric acid, and sulfuric acid. These you need to know. Strong acids mean strong electrolytes. And acids, the strength of the acid depends upon polarity of the bond and the bond energy. So the amount of energy needed to break that bond. The lower the bond energy and the higher the polarity, the stronger the acid. So let's look at weak acids. This releases a few hydrogen ions into an aqueous solution, and it contains the hydronium ion, the anion, and the dissolved molecule in the aqueous solution. So the acid molecule, because it didn't completely break up into ions. So we have examples, hydrocyanic acid, and then we have organic acids containing the COOH group, COOH, COOH. Like acetic acid. Acetic acid has that COOH group, which is known as the carboxylic group. So, Arrhenius bases. We said that the base increases the amount of the OH minus, the hydroxide ion, the hydroxide anion. So, when it dissociates in water, we see NaOH. We have some water, we get two ions. We get the sodium cation, and we get the hydroxide anion. So if we look at ammonia, which is molecular, we see that ammonia produces hydroxide ions when it reacts with water. So we have ammonia, water, and we can see that it has hydroxide ions, therefore we know that it's an Arrhenius base, and we get this. What is this called again? The ammonium ion. Good job, guys. Great. Also, just to add in, because they are ionic, most of them then dissociate easily into their ions. So they break up into their ions all easy because they're ionic. Hey, look at that. So, base strength then depends on the extent to which the base dissociates. Once again, strong bases equal strong electrolytes. So we have calcium hydroxide, barium hydroxide, sodium hydroxide. We see that it dissociates into its ions. This is a strong base. Then we get to weak bases where we see that it just kind of has both in the solution. It's kind of like the acids where it doesn't fully dissociate into its ions. Look at the relationship of the hydronium ion and the hydroxide ion. We see that if the hydronium ion is greater than the amount of the hydroxide ion, it's an acid, and we'll talk about that later when we get to pH. So if we see that they're equal, it's a neutral solution, and then if we see that the hydroxide ion outweighs the hydronium ion, it's a basic solution. So we can see that it's kind of on a teeter-totter. Over here, H3O plus, it's a little bit heavier, a little bit more, has a bigger amount, so it's an acid. We see here, OH minus has a bigger amount, it's a bit bulkier, it's bigger, so it is a basic solution. Thanks guys, tune in for section 2. Bye!